think we should have.
All right, we are ready for. Well, some of us are ready for. Okay, so lesson 13. Here we go.
No.
Well, I want you to look at what it says. I can reason using benchmarks to compare two fractions on the number line. Did I do that?
Yep.
That sounds an awful lot like what we did yesterday, doesn't it? Okay, and it is what we did yesterday, except today we're going to kind of keep going and look at a little bit bigger fractions and a little bit different piece of the number line. So keep that in mind. We'll come back to those thoughts in a minute. We're going to get going here. I really am not going to use their review questions. I'm going to go to my own. Here we go. Let's throw away stuff we've thrown away 50 times. Okay, here we go. Throw you away. Yeah, who knows? All right, so let's do some multiplication here with. Okay. You might want to do this if that helps you remember one of our steps. Get started, guys. All right, let me jump in here, but please keep working and see if your answers match mine. 6 times 7 is 42. That slowed some of us down right there. We're going to put the 2 and carry the 4. 6 times 5?
30.
6 times 5? 30 plus 4 more is 34. So your top row should be 342. Cross out that 6. That reminds us to put that dinosaur egg, that 0 right there, and then we move on to the 4. 4 times 7? See, that's not how this works. We're in the second semester. We're beyond Christmas. So, ready? Here we go. 4 times 7?
28.
All right, there we go. 28. Well, you should be awake now. Okay, and then 4 times 5?
20.
20 plus 2 more is 22. So your second row should be 2,280. Yes. Okay, let's see. Add that up. 2,622.
I got it wrong.
What?
I was multiplying 59 times 2 there.
Which one? Where?
I was multiplying 59.
Oh. You know what? Can I say that out loud?
Yeah.
Can I share that? You know what? You've got to copy the problem down correctly, don't you? Okay? Because if you miss a digit, you might have multiplied right, and this is probably the correct answer for this. But if you don't copy what's up there, that could mess you up, couldn't it? Yeah.
I can share one of my copies.
Okay.
I accidentally forgot to put the 2 down.
Ah,
On
like here?
22, yeah.
Okay.
And multiply by 5 times 4.
Definitely can mess you up. All right. So sometimes when we share these mistakes, or y'all let me share them, it really helps all of us. Yeah.
I forgot to put my, when I was rounding.
Rounding?
Or not rounding.
Hold on.
When
I see the problem.
For the 2 and the 4s, I forgot to put it up
Okay. Okay. And so y'all are catching yourself. You know.
I got it right.
Good for you. All right.
I'm not gonna get it wrong.
Woohoo, Martin. Okay. The rest of you, we have work to do. No, I'm kidding.
Yeah.
All right.
No.
All right. Here's a little bit different problem. You can go ahead and clear that off. Here's a little bit different problem.
I'm gonna get this one right too. Oh, never mind.
Okay. So on your board, I want you to write the factors of 24. If you want to use the little arcs to match them up, you can do that. That was a huge hint I just gave you. If you'd like to use the little arcs to match them up, go right ahead. That's a huge hint that I just gave you. Yeah. All right. There's several, so get started.
What's the hint?
I got it.
I knew it.
Several of you did catch my hint, because by me telling you that you could use the arcs, that told you you weren't skip counting forever. Okay, hopefully that gave you somewhere to start. All right, we know 1 times 24 is 24. What's another one? 2 times 12. We know it's an even number, so we know 2 is in there somewhere. And 2 times 12 is 24. What else do we know? Yeah. 3 times 8 for sure. What else do we know? Yeah. 4 times 6. Now when you get that many, because those are a lot of our basic facts, when you get that many and you go, okay, well, you know, these numbers have come this way and these numbers have filled in here, and the only number left between those two is a 5. Does 5 go into that? Is 5 a factor? No, because this does not end with 0 or 5. We're done. Okay, we have found them all. All right. What if I asked you to write
Oh.
I asked you to write the first 4 multiples of 4. Okay. Different than factors. You're not going to do this one just like what you just did. There's a reason that I'm saying this. Because if I don't say that, they're going to be here a while. You just need the first 4. You're good. All right. What are the first 4? Help me with what is the very first one? Reagan? No. Reagan? 4. Okay. Charlotte, what's the next one?
8.
Bailey, what would the next one be?
12.
And the last one that I asked for would be what, Valerie? 16. All Alright, 4 times 1, 4 times 2, 4 times 3, 4 times 4. Alright, and you're basically skipping multiples by 4. Okay? Oh, stand up by your desk. Sure. Here we go. Cheesy face, though. If you don't have a cheesy face, sit down, please. Come on. We need your help, Ishmael. It's not the same without you. Come on. Come on. We need you. Kennedy, come on. Gage, come on. It's Friday. We gotta have a little pep in our step. Here we go.
Multiples.
Oh, one more time, just for old time's sake. Here we go. Ready, and?
Multiples.
Okay.
Gage didn't do it.
He did it in his own way. I saw him. He did it in his own way. He's fine.
4, 8, 12.
Okay. Now, I need you to put your marker board just off to the side. Your hands off of all of that. Lay everything down. Okay. I need to ask you what we did yesterday. Because that's going to lead us into today. What did we do yesterday, Mason? Go ahead.
We used a number line to do different fractions.
Okay, we used a number line. What were we doing with those fractions? What were we? You're going to add on? Go ahead and add on to that.
Well, there was 3 fractions. We were trying to find the number of the fraction on the number line. There was 4 number line with all of them.
Okay, so we had a number line. We put fractions on the number line. For what purpose? What was our purpose in putting those fractions on the number line? We were trying to see something about them. Yeah?
We were trying to figure out which one was bigger.
Yeah. And in math, that's comparing. A lot of times when you hear the word compare in math, you're trying to figure out, is this smaller? Is it larger? Are they equal? Okay. So, we had a number line. We put fractions on the number line. We were trying to compare them. Now, what method or what was something that we used, and there was more than one thing, to kind of figure out, hey, this fraction's bigger than this fraction? What were some things we did yesterday? Think about it.
We looked at the numerator and like the denominator was the same.
Mm-hmm.
And we looked at the denominator and the numerator.
Okay. So we checked out the numerator and denominator. Sometimes that gave us a clue as to which one was larger or smaller. What else did we use or talk about yesterday? Think about what we did. Okay, let's put all that away, please. Away. Yeah. We definitely used benchmarks. Now, what were our benchmark numbers yesterday?
1/2 and 1 whole.
Okay, 1/2, 1 whole, and then sometimes we include 0 just because that's our starting spot. Okay, so yesterday, 0, 1/2, and 1 whole. And that's how big our number line was yesterday, wasn't it? Started at 0, went to 1. Okay? And then 1/2 was in there somewhere. Okay? Anything else that we used? Nobody's mentioned this one thing. You all have it. You all use it every day. I did this a whole lot yesterday.
Your brain.
We are definitely used our brain. Yeah.
We drew a model.
Our number line was our model yesterday. Okay. So a little different than our tape diagram, but our number line is a form of a model. Yeah.
We looked at the halfway point and we looked at the.
And that was our benchmark. We definitely did that. What is that word that talks about using this thing up here?
Mental math?
Well, it was a form of mental math, but the word we used yesterday started with an R. Kind of means to think things through, use what you know. Start with an R. It was on the big screen a minute ago, and I read it to you. R E
Review.
A S
Revise.
O
Register. Revolve.
N reason. There you
I
go.
knew that.
Okay.
Dang it.
Didn't say it. Y'all are giving me every R word. Robot. No, you're a little off there. No, we were reasoning. We were using what somebody in second period called a very, like an educated guess, where we really use clues that are there, that are, smart guesses as to why something would be what it is, okay? All right, we're going to continue with that. Before we go any further, I'm going to, let's see how well this one's working. I want a marker that draws dark all the time. Huh? Oh, thank you. Okay. I turned around there and got really crooked. You know what? Okay. See, I hate that. Because there have been times where I've written, and then I go stand in the back of the room and I'm like, nobody can read that. What was I thinking?
Yes, Wendy, you want one of my big markers?
No, I'm just going to keep struggling up here.
They got darker.
Yeah, much better.
Oh, I can't see it now.
Okay, a little better.
I can see it.
All right, so if I had on this, now of course all my magnets are over here.
I like this. This is a delay of class.
A delay of class? No, we're still having class, I promise. All right, so if our number line went to 1, of course I could just write 1. It'd be a little quicker. And 1/2 was right there in the middle. Okay. Let me grab some more of these.
She has blue, red.
She has a rainbow.
I want to come off the board. All right.
You'll never put me up there. You will never put me up there.
Oh, I got the easiest.
Okay. I'm not going to hand one to every single person that don't have that many. Just, I think it's the first time all year I've done that. Sorry.
Well, maybe
Okay.
Charlotte.
All right. We'll pass these out to different people on another day. Okay? Now, if you got one of these, what I want you to do is go and find somebody in the room and just, not yet, have a seat, when it's your turn. And you're going to let that person that doesn't have one help you. Where on the number line is that fraction going to go? Okay. So, this has to be supersonic fast because we still have our whole new lesson to get to. All right, Martin, super fast, go grab somebody. Ask them if you're right. Bailey, you go ahead and be talking to somebody too. Somebody that doesn't have one. Most people are the Jayla back in the back. Some of them don't have one. All right, where does it go? What have you got? Tell everybody what you've got.
1/4.
Where does 1/4 go? All right, so you think it goes there? Anybody agree or disagree with Martin? Okay, definitely a good spot for 1/4 because it is smaller than
1/2.
1/2. The larger the denominator, the smaller the fraction. Okay. Come on up. Do you have figured out where it goes? You go ahead and be asking somebody. Okay. You've got what? 6/8. Where do you think it goes? Somewhere in here. Why?
Because it's 2 away from 1 hole.
Okay, 2 away from 1 hole. What is halfway? Guys, be listening. What is halfway when we have 8s? Yeah. 4. So 6 is more than 4. So that's another way to know. All right, excellent. Good. Okay. Isabella, come tell me where this goes. Go find somebody to ask that does not have a card. What have you got? 1/12. Where do you think that's going to go? Down closer to 1. Okay? Is 1/12 going to go way down here? Hold on. All right. I'm seeing some disagreement. Why? Where would this go?
It would go at the beginning, the very beginning.
How do you know?
Because it's 1/12.
Okay, I know that, but what about 1/12? What do we know?
Past the halfway point.
It's not past halfway because 6/12 would be halfway. What do we know about 12ths? How big or small are they compared to fourths?
They have smaller pieces.
Much smaller pieces because the number on the bottom is bigger. The piece is smaller, so it's going to go way down here. Okay? All right. Let's keep going. All right. Come on up, Charlotte. Gage, you can go ask somebody. If you know and you don't need to ask somebody, that's fine. But if you need to ask somebody that doesn't have a card. All right, what have you got? She's got 1/6. Where do you think that goes? All right, right here between 1/4 and 1/2. All right, think about it though. This is one piece, this is one piece, and these are sixths. Where does that need to be moved to? I'm going to tell you it needs to be moved. Reagan, where?
It needs to be moved between like that little space and that one.
Like here?
Yeah.
Okay, because why?
Because it's 1/6 and it doesn't go past the halfway, and it's not like 2/6 that would go like that.
It's bigger than 12ths, but it's smaller than 4ths. So yeah, it's going to go way down here. Okay, we got to remember that about the size of our pieces. All right, go find somebody to ask if you need to. Go find somebody to ask if you need to.
He already has.
You already have. All right, come on up. Where do you think yours goes? What fraction do you have? 4/5. Where do you think it goes? All right, before the 1/2. Okay, what is half? Guys, what is half when we have 5 pieces total? 2.5, actually. That's kind of weird, but 2.5. So it's actually going to be on the other side. Yeah, it's going to be closer down here. It's going to be closer. Yeah, because it's past 1/2. Okay, Alex, come on up. Faith, go ask somebody if you need to. Ask somebody that doesn't have a card. What have you got? 7/10. What is half when you have tenths? 5. So is that past 5? It for sure is. Good. All right. All right. Does anybody else have a card? All right. I'll try to start on this end and pass stuff out the next time we do something like this. All right. What do you think? What is the fraction? Show it to me. Okay. Where do you think that's going to go? Think about half. You know, is it going to go before 1/2 or after 1/2? After 1. So you think that's bigger than 1/2? Okay. 1/3. Is 1/3 bigger or smaller than 1/2? Smaller because it's got a bigger denominator. It's a smaller piece. So let's come find where it goes. All right. Here are denominators: 12, 6, 4. All right. It's actually going to be between 1/4 and 1/2. Okay. So just put it right there. All right. So that's just giving us some practice putting fractions on a number line. Now we didn't draw, you know, if I'd have drawn all the little tick marks and y'all could have counted where they go, it would have been a whole lot easier. But we're using our reasoning skills to figure out, oh, this is smaller than 1/2, this is larger than 1/2, this is closer to 1. Okay, and I did hear some of that talk. All right. Let's jump in here. Right there. Let me go back. Okay, now there is not a number line right now, but there will be, so don't worry. Okay, because the number line is, I think some of you are starting to see that it is a helpful thing, not a thing to run away from. Okay, so with our number line, let's talk about these two fractions. In just a second, we're going to find where these two fractions go on the number line so we can see which one is bigger. What can you tell me about these two fractions today? Look at them. Do you notice anything about them? If not, we'll just jump right in. What do you notice?
6/4 is an improper fraction.
All right, Caleb says this is an improper fraction right here. Okay.
Oh,
what do we remember about improper fractions? You know, is there something we might need to be aware of? Yeah.
The bigger number is always going to be on top.
Yeah, that's an improper fraction. The larger number's on top. What does it mean when the larger number's on top? Yeah.
it means there's a hole and then like more pieces added to it.
So this fraction is actually bigger than what number?
7/8.
It's bigger than 1.
Oh.
Okay. But it's bigger than 1. Our number line has stopped at 1. So what are we going to do if our number line is not a number line? What are we going to do if our fraction is a number that's larger than 1? What do you think?
Add 4 more pieces
Add more to what?
to the number line. If there was a number line, we could.
Oh, you're saying so if we have a number line, make it longer?
Uh-huh.
Okay. Is that what you were going to say? Or go ahead, Reagan, and then Faith off of you.
You could draw like a tape diagram.
Okay, but we could, but we're going to stick with our number line right now, okay? I'm not letting you do that, even though you might want to, okay? Yep. We could let our number line go all the way to 2. Okay, let me ask y'all that. The number line, even if it says, look at our number line right here, even if it's, 0 to 1, what do these arrows on either side of the number line really tell us? Why do we do that every single time we draw a number line just about? Why are those there? What does that mean, do you know? It does mean something. To help you remember, what would you say? Okay. That's okay if you want to guess. We're just kind of guessing right now.
Like, it means you could go on,
Absolutely. You're exactly right. Our numbers go on forever in both directions. Both directions. You mean below 0? They really do. And you guys, what's nice is you right now, you don't have to worry about those. You'll learn about those as you get older. Those are, that's where you get into negative numbers. And those will make more sense to you later on. But our number line could go on either direction forever. And so when you see that, that's what that means. So we could choose any part of the number line to look at. Like I might today want to work with this section of the number line. Another day I might need to work with another section of the number line. Yesterday we worked with the part of the number line that started at 0 and went to 1. But like some of you just mentioned, we are going to change our number line a little bit today. We're going to show a little bit more because we need a little bit more.
So I was right.
You were right. Now, so let's put a number line up here and just watch for right now. We'll try some on our board in a little bit. But let me stick a number line right there. And we're going to let, we shift it a few times, so let me double check. We're going to start this one at 0. And we're going to go to 2. Now, a smart thing to do is to put anything on the number line that you already know that needs, that could go there, that you already know belongs there, because we could use any little benchmark, any little help we can get. So what is missing between 0 and 2 that is easy for us to put on there? Faith? A 1 for sure. Okay, so where would that 1 go? Yeah, go ahead. Right in the middle. Okay, so we have 0, 1, and 2. We have those whole numbers. Those are easy for us to put on the number line, so go ahead and put them because they're going to help you put everything else. Okay, now let's jump back down to these. 7/8. Where about would 7/8 go? Think about 7/8 and how big it is. Okay, we know 8/8 is 1. We know 4/8 is half. But guys, don't forget, this time half. 1/2 is right here. Well, isn't 1/2 between 0 and 1?
Yes.
It's almost like somebody has taken a camera and backed up, and now they're showing you a little bit more of the number line. They've just got, it's like before they were zoomed in on just this much. And now it's just like they backed up, and that much is still there. But now we can see a little bit more. All right, what do you want to say? I like how you said that. Okay, please watch this, guys. I want this to help you. It's going to be between the 1/2 and the 1. It is. Anybody want to add to that? Be a little more specific? What do you think?
Right before the 1.
Yeah, it's only 1/8 away from being at 1. So it's like right here. Okay, so that's our 7/8 right there. Now, are we exact right now? I mean, did we measure it out? Did we draw every little tick mark? No, but that's okay. It's okay to do it like this with our reasoning today, okay? Now, what about 6/4?
Ooh.
Yeah, that becomes weird, doesn't it? Right, it's not so much weird, it's just different. Let me say it that way. Reagan, what do you want to say? And then we'll go to Mason.
6/4 would probably go to like maybe just a little bit 2, like a little bit before 2.
A little bit before 2. Because you've already told us that 6/4 is bigger than 1. So we're going to get to the 1 and go past it. What do you want to add? So some of us, let me ask this question. Some of us are already seeing kind of about where this is going to go. How many of you right now, guys, I need markers put away. I need hands away from stuff. I've got to have your eyes right now, okay? How many of you are looking at this and you're like really, really not sure where it goes? Are you willing to say, be brave enough to raise your hand if that's how you feel, and that's okay if that's how you feel. I want to show you something that we're going to do today to help you, okay? All right, but I got to have you with me for this to make sense. When we have a fraction like this today, and it's an improper fraction, we're going to create a number bond. I'm going to show you why. Okay, this will be at the top of the number bond because what we're going to put below it will add together to make this. If we pull this apart, it's going to help us see where it's going to go on the number line. Okay? Now, Mason, you were already saying some things that are going to help us with this. I don't know if you realize that. All right, think about fourths. Reagan's already told us this is larger than 1. So anytime you have a fraction larger than 1, it's an improper fraction. Pull out the 1. Okay, pull out the 1. What do we mean by that? How many fourths does it take to make 1 whole? Everybody needs to know this. Say it again.
4.
Okay. If I have fourths, my pepperoni pizza right here is cut into fourths. How many pieces do I need to make the whole pizza? 4, right? 4 fourths. Any number over itself is equal to 1. Y'all didn't do this like second period did. Y'all stand up. Stand up. Here we go. We got to remember something. Here we go. Please repeat after me. Any number over itself is equal to 1. Cha, cha, cha. Okay, let's do that again. Any number over itself is equal to 1. Cha, cha, cha. Okay, now it's early morning. They have a little more swag to their cha, cha, cha because they're awake in the afternoon. So, all right, get with me. Hop up. Let's go. One more time. We're doing this because I want you to remember this. Here we go. Any number over itself is equal to 1. Cha, cha, cha. Okay, but you got to echo. Here we go. We're going to do it fast. Any number over itself is equal to 1. Cha, cha, cha. Okay. Have a seat. Yeah, but weird helps you remember sometimes. Okay. So we're going to pull out the 1. How many fourths does it take to make 1? 4. So I'm going to pull out the 1, which is the 1 whole is 4 fourths. Okay? Now, once I pull 4 of those out, how many are left? If I've got 6, I take away 4. How many are left? 2. 2 fourths. Okay. This fraction will go all the way to 1, and then it'll go 2 more fourths. What is 2 fourths?
1 half.
1 half.
2
Okay.
halves.
So we're going to go all the way to 1. Let's change that color. Let's go here.
No purple. I mean blue. Yes, I got it.
This fraction right here is going to go all the way to 1. And then it's going to go 2 more fourths. And y'all said that's about half. So it's going to land right here. So that is 6 fourths. Okay? So anytime we have that improper fraction, if you will pull out, how do we know how to do this? Whatever the denominator is, pull out that many. 4 fourths. That gets rid of the 1 whole. And then you can see what piece is left to know how far to go past 1. Okay? All right. Any questions here? What questions do you have for me? Yeah.
When you go past 1 and you're not, will you call that 2 halves?
When I pass the 1, I've got 1 1/2. Okay, that's a great question, and we're going to get into that a whole lot more later on. Okay, you can call it 6 fourths for now, but it's actually 1 1/2. Okay, so which one of these fractions is larger?
6 4.
6 fourths is larger.
1 and 1.
Now, the number line's great. And if you need to put those on the number line, then that's one way to do it. But I'm going to show you something else. You know how we've been using our reasoning? I didn't even need a number line at all to answer that question. And this is why. Is this larger than 1?
Yeah.
No, it's almost 1, but it's not quite. I know immediately this is bigger than 1. You see the difference? This is smaller than 1. This is larger than 1. Boom, I know the answer. This one is bigger. Okay? So you can use your reasoning skills, but there is a time to know how to put it on the number line. We need to know how to do that too. Okay? All right. Let's move on to a different set. We're still going to use that same size number line, so I'm going to put it back for, being helpful to us.
They're both in proper.
Okay, hold on. This is 0. This is 1, and this is 2. And we have that in case we need it.
Which one's bigger?
Okay. Now, I heard it said these are both improper fractions. Dun, dun, dun. Math just has to stop right now because this is too hard.
Yes, please, just stop.
Now, a minute ago, or a second ago, I was like, okay, if one is smaller than 1, one's larger than 1, you immediately know which one's bigger. But what if they are both larger than 1? Now, what do you think I need to do to both of these? Mason, what do you want to say? We could just start at the 1, couldn't we? Yeah. If they're both bigger than 1, we don't even need this part of the number line, do we? That's what he's saying. You're right. Okay. Well, let me show y'all something. I don't know if this will help somebody. Y'all remember our number lines are on the floor, and I know this is not easy to see for everybody, but this number line that's closer to me. And I know that Mason is right. We don't necessarily need that part of the number line, but I'm just going to go ahead and put it. There's 0, and then 1 and 2. Same number line that's on the board. Okay, so if that's 0, and we call I wrote on the wrong side. Call that 1, and that 2, and of course then that would be 3, and so on. We could keep going. All right, let me ask you something. If I had, Isabella, come help me for a second. Okay, just stand beside me. You stand on this line, and I'm gonna stand right here. All right, if we are both up here, and let's say we're running a race, and we're trying to see who has run the farthest, okay? And we both, come with me, and we both get to 1, okay? Both of those fractions have gotten to 1, but they've gotten bigger than 1. Don't we need to know at this point who has gone farther past 1? to know who's winning the race? Okay. Maybe Isabella's gone, you go right here, that far, and maybe I've only gone this much past 1. Okay. Maybe on one of these fractions it's gone way past 1, and maybe one of these fractions has only gone a little bit past 1. So we know we both got to 1, but right now we need to know who got the farthest past 1. Okay? All right, you can sit down. So that's what we need to look at with these. Where'd I put my pen, y'all? Well, I don't either. There it is. I've always said they don't need to make these white because I lay it down on something white and then I can't find it. It needs to be neon yellow. But anyway.
Don't make them black.
No. Something really bright. So we need to know how far past the whole number 1 each of these has gotten. So we are going to do that number bond thing. Okay. Now, on your board, kind of in the bottom half, let's make a number bond. Let's get some practice doing this together with 5/3. Okay? What are we going to pull out first? What did I tell you we need to pull out? Pull out the 1. What is 1 when you have thirds?
1, 3.
3 what?
Third.
3/3. So we're going to pull out 3/3. I know that number bonds usually have circles around all of them. If you, sometimes on the bottom ones, I don't put the circles. It still means the same thing without the circle around it. If I pull 3 of these thirds away, I've got 5 of them. I pull 3 of them away. How many are left?
2.
This is a simple subtraction problem. 5 take away 3 would be 2/3 are left. Okay? So this fraction went all the way to 1 and then went 2/3 past it. What about this guy? Okay? We might not need to make our number bonds quite so large. I want you to do one of these, this one as well. What would we pull out first, everybody? 5/5. And what would we pull out second? What and 5/5 is going to make 9/5, Caleb? 4/5. Make sure you said. I thought I heard 4/4. Yeah, 4/5.
They're both 1 away from 2 holes.
Okay, and that's important, but we'll talk about that in just a second.
I know.
All right, this guy went all the way to 1 and then went 4/5 past. Okay. This one is 1 away from 2, actually, but 1 away from the next whole number, and this one is 1 away from the next whole number. But we've got a 1/3, and we've got a 1/5, and I don't have a 1/5. Is the 1/5 going to be smaller or larger than this?
Smaller.
Smaller. So which one has more distance to get to the next whole number?
9/5.
No.
No.
This one's
5/3.
This one's closer to the next whole number. This one has got more distance to go because thirds are bigger. Okay? So 9/5 would be larger. Okay? But where would they go on the number line? 5/3 goes all the way to 1 and then goes 2/3 more, right about there. If I picture this cut into thirds, 5/3. This one goes all the way to 1 and then goes 4/5. Fifths are smaller, so it's going to go right about here. They are very close together, but they, one of them is closer to the next whole number than the other. Okay. All right. You can clear this off your board. One of the things we have to pay attention when we do this, and when we go to our problem set, we'll need to be looking is where they have put the whole numbers on the number line. Did they start at 0, or did they actually start at 1, or did they start at 2 and go to 5? Sometimes that'll happen, okay? Don't let that throw you off. It's really all basically the same stuff. Okay. I think the number line has changed this time. Let me double check. Yeah, this time we're going to start it at 1 and go to, I believe it's 2. Okay, here's the big question for you. Go ahead and draw your number line at the top. Go ahead and start it with 1 and end it with 2. Your little arrows. But what I want to know is what would go in the middle of our number line, right here. Because we like those benchmarks. We like those things that help us know, Ishmael, what do you think? It has something to do with half, but not 1/2. 1/2 is down here before 1, because 1/2 is smaller than 1. What do you think?
1/2.
Okay, 1.5. Okay, so this would be 1.5 together. Because haven't we already gotten to 1?
Yes.
And then we have another half with that. Okay, so 1.5. Like somebody going 1 and then 1/2. You got all the way to 1, and then you got another half. Okay. All right.
She just threw that pizza in the
What do we need to do?
She said, "Yeet."
How can we figure this out? All right.
Find where my horses. No, you need 11.
Find where both of them are. What do we need to do to help us? We know they're both bigger than 1, but we don't know how much bigger than 1 they are. So what do we need to do? Yeah. What would help us?
You have to draw
the number bonds. All right, so down below your number line, if you would make this a number bond. We're going to pull out how many pieces here to make 1 whole? Yeah. Good. 8/8. Okay. And once we get rid of, kind of pull that out, we can see how many 8s we have left. How many 8s do we have left? 3 8s.
I said 3.
Because we know 8 and 3 is 11. Okay. Now do the same for the other fraction. Because they're both larger than 1. What are we going to pull out here to show us 1 whole? How many pieces? Yeah.
4/4.
4/4. Because any number over itself is equal to 1.
Cha-cha-cha.
Cha-cha-cha. Okay. I hope when y'all are like 25 years old, you're explaining that to somebody and you add the cha-cha-cha. Yeah. All right, so if I've pulled out 4 of those fourths, how many fourths do I have left?
1/4.
Yeah, because this 1 and 4 makes 5. So 1/4. So you know what I really need to focus on? I need to focus on this piece and this piece. All right, they both went to 1. This one went to 1 and then went to 3/8. And this one landed on 1 and then went to 1 more fourth. Okay, so let's do that. This first fraction went to, where's 1? Right here? Okay, first of all, what in the world is that? What is that?
1.
Did I start talking and get distracted?
1.
I believe I got distracted. There we go. Sorry.
There used to be 2 there.
Did it erase?
Yeah, there was a 2 there.
Okay, maybe I hit undo or something.
What's undo?
All right, did you see what I was about to do, though?
The arrow.
Hold on. Did you see what I was just about to do? Remember the number line that I had before this one?
Yeah.
It was 0, 1, and 2. And just a second ago, I started to go, okay, 1, and then that's not 1. Pay attention to your number line.
1/2.
I know. All right, so I need to go, look, I need to go to 1 and 3/8. So 1, now let's, 3/8. What do we know about 3/8?
It is
It's what?
close to half.
Is it half?
Almost.
Almost. It's not, though. It's not this big. So 1 and 3/8 would be right before 1 1/2. 1 4/8 would be 1 1/2. So this is 11/8 right here. All right, this one is going to go to 1 and then go to 1/4. So if this was cut into fourths, I'd go right about here. 5/4. Which one is bigger? I wonder if that's what we thought would be the biggest one before we started.
Totally.
Be careful though, sometimes when your digits are larger, the pieces are smaller, so.
I had that. No, you didn't. You're over here.
Okay. All right. Let's do one more.
We learned more today. And I'm tired.
Okay.
I have no energy.
I'm tired. These are
I
hard.
wish they made.
I don't want them.
I wish they made kid Red Bulls.
Guess what's happening in this room? Even though I wanna is also happening. Your brains are growing because you're making yourself do hard things.
I wish they made kids energy.
Okay, hold on. What?
The more we do today, next week we don't have to do that much.
Well, next week will be easier because we understand more from today for sure.
I still don't like you.
Okay, draw your number line.
Let
But Martin, have I thrown anything to you without helping you out and without working through it with you?
No.
We're good. We're good. So even though this might be stretching our brains a little bit, we're good. And I've got you, and we're gonna be fine. Okay?
It's gonna be all. I need to wake up.
On your number line, go ahead and let's put the 1 and the 2. Let's put those back, and right in the middle, let's put 1 1/2 again. Okay? 1 1/2. All right. We just did 11/8, but we're going to go ahead and make that number bond one more time. But we know what it's supposed to be. How many 8s did we pull out first? 8 8s, because that makes one whole. And when we pull 8 away from 11, how many do we have left? Okay, let's put that back. We had that already. What about this one? What am I going to pull out to show one whole, Faith? What am I going to do? 6/6. Okay. If I pull, okay, not okay. If I pull 6 away from 10, what am I going to have left? Well, take 6 away from 10, I'm going to have 4 6 left. Okay, so I need to look at this, and I need to look at this. But I need to make sure that I go to 1 and then go that far. Okay, I go to 1 and then go to 3/8. Y'all told me that was not quite to the halfway point. Okay, where is 1 4/6 going to go? Is that bigger than half?
Yes.
What is half when we have 6?
3 6.
3/6. So this is going to go farther than half. So we're going to go to 1, and then we're going to go a little past half. Well, here's 1 1/2, so a little past half would be close to here. So which one of those is larger?
10 6.
6. Okay. All right.
Are we done? No. Now's the time to take naps. Yeah, I wish it was like pre-K.
Okay.
They don't take naps anymore. Yeah,
Go ahead and clear off your board and set it down, but just lay everything else down too. And we're not done, but we're just going to talk through this. And we're not going to draw a number line because guess what? Just like we could reason and think through the smaller fractions, we can do the same with these sometimes.
You know which one's right.
All right. Let's think about these.
Ooh.
Okay. We're going to reason through them, but we still got to know how big our pieces are. So we're still going to do that number bond. That's something we're going to do a lot of. Okay, Valerie, when I pull out one whole, what am I going to pull out first? Look at your denominator. That's very important. Any number over itself is equal to 1. So what is 1 going to be right here? Say it real loud. I can't. No, we've got tenths here. So how many tenths do I need to make one whole? Any number over itself. Help her out, everybody. Okay. That's going to equal one whole, okay? If I take 10 away from 14, everybody, what do I have left? 4. So 4 tenths. Okay. All right, let's go ahead and do this one, and then we can start reasoning. We can start thinking. What am I going to pull out here? Jayla, what am I going to pull out to make one whole? These are fifths. 5 fifths. That's going to be one whole. And then if I take 5 of those away, Bailey, how many will be left? 2 fifths. Okay. So I'm going to focus on this piece because this is equal to 1. And this is equal to 1, but I need to look here. They both go to 1, but then they both go a little bit farther. Which one goes the farthest? All right, what do we know about 4 tenths? Think about what we did yesterday. You know, what's the halfway point with tenths? 5 tenths. So does this go to 1 1/2? Does this go all the way to 1/2 right here? It's a little bit smaller than 1 1/2. What about this one? 2 fifths. What is half when we have fifths?
2 halves. It's an odd number.
It is odd, so it'd be like 2 1/2 fifths. It's an odd way to think of it. Okay. So which of these goes farther? They're both smaller than half.
I think it's 7 fifths. It's equal or 7 fifths. I think equal or 7 fifths.
It does make sense.
It's equal or 7 fifths. No,
Anybody want to add any thoughts here to help us? Because we're all kind of like, I don't know, they're both close.
I think
Reagan, what do you want to share?
I think it's 7 fifths because they have bigger pieces and it's closer to a whole because it's only 3 away from 10 and then 14 tenths is 6 away. So I thought it'd be 7 fifths. I think no. Equal.
You think they're equal? Ah, interesting.
7 fifths. It's 7 fifths or it's equal. Hold on.
Well, no, I'm. Yes, but not this way.
I have a weird feeling.
I wanted to check something.
7 fifths.
Any other thoughts?
Equal or 7 fifths? That's not 7 fifths.
Yeah, it's either equal or 7 fifths.
Yeah, 7
Okay.
fifths.
Which one was right?
Okay.
I would say equal 7 fifths. Equal 7 fifths.
Yeah. Next week we're going to keep going with this, and we are going to keep learning some strategies that you're going to like probably better than this.
Yeah, I don't
Okay.
think so.
Yeah, because I don't like
But we've got to understand what's happening on that number line, even if we have a quicker strategy than this. Okay. All right. Any questions for me? No. Any questions about the work?
Can we take a nap?
All right.
I have a question.
Okay, that's why I clarified questions about the work.
I have a question.
What's your question?
Are the strategies we learned going to be easier than this?
I think some will think they're easier. I think some might like this better. Okay.
I don't like this.
Okay. In just a minute, when we go to the problem set, very similar to yesterday, where we're going to, guys, I need your eyes and ears. Okay, I need you not to start being distracting to other people. We're gonna plot these fractions they give us on the number line. We are not going to put every little tick mark this time. We're going to kind of guesstimate where they are. Makes it a whole lot easier to see when we've got too much going on the number line. It makes it difficult. Then we're going to use that to help answer the rest of the questions. When we get to the back side, this is just like yesterday's. The fractions are just a little larger. They're going to give you problems like this where you don't have the number line and you're going to create your number bonds and then use your reasoning to decide which one is larger. Okay. All right, so let's put away our boards and markers and lay your workbook out, and we will take our quick break and come back and go over these or get started.